Hello and welcome to ACT Math Prep. This is Session 2, Algebra and Functions. I'm Sarah Gale, your instructor. So the topics in the ACT Math test that are included are number and quantity, algebra, functions, geometry, trigonometry, statistics, and probability. I've divided these into 4 class sessions. Session 1, number and quantity. Today's session, algebra and functions, geometry and trigonometry, and finally, statistics and probability. This is session 2, algebra and functions, and the things you are expected to know are be able to solve, graph, and model multiple types of expressions, including linear, polynomial, radical, and exponential expressions. Solve systems of equations, and understand function definition, notation, representation, and application, including linear, radical, piecewise, polynomial, and logarithmic functions. You should also be able to manipulate and translate functions and their graphs. And finally, apply important features of graphs. When you're working on a test like the ACT test or any sort of activity where you sort of need to work independently, it can be very important to know about metacognition or understanding how you think. The first step is to assess the task. Next, you need to evaluate your own strengths and weaknesses and use those to make a plan of attack for how you're going to approach the ACT test. Then when you're taking the actual test, you're going to apply the strategies that you planned on and monitor your performance as you go so that you can reflect on how you're doing and adjust if needed. So be sure that you have gone to the Google Classroom and clicked on the Classwork tab, and that you have downloaded the Session 2 Algebra and Functions worksheet and printed it out. You can pause this video and do that now if you haven't done so. And we will move on now to the practice problems, work through the worksheet together. Let's get started with our problems. So our first problem asks, which of the following expressions is equivalent to a times 4 minus a minus 5 times a plus 7? When you're multiplying expressions like these in parentheses, that's a clue that you're going to need to use the distributive property. So, if we have a times 4 minus a minus 5a plus 7, in order to multiply these and get rid of those parentheses, first we have to distribute this a to both terms of that binomial. Binomial means 2 terms. That thing inside the parentheses has 2 terms, 4 and a negative a. It's a binomial. So, we have 4 times a minus a times a, that's a squared. Next we have to distribute the negative 5. So be careful with this. That's a negative 5. A lot of kids think, oh, it's a minus sign and they don't take it, but if there's a minus sign in front of the number, it needs to go with that number always. So start thinking of things like that as a negative 5 and not necessarily a minus. So negative 5 times a, and then negative 5 times positive 7 will be a negative 35. Okay? So now, when you have terms like this, with squareds and single terms and numbers, we generally like to put them in order. So remember what I said before about the negative staying with the number it's in front of, right? The highest order term is that negative a squared. And then you can see we've got a 4a and a negative 5a. Those are like terms. They can be combined because they both have just a single a. So positive 4 and negative 5 leaves negative 1a. And then finally we have our negative 35, and you can see that the answer is C. For our next problem, it asks if x squared plus 4 equals 29, then x squared minus 4 equals what? So this is an interesting problem, and these occur frequently on the ACT test during the algebra and functions type of problems. This is where you're not actually solving for something, we're not solving for x. What we're doing is kind of manipulating this equation. So if we were to solve for this, of course, you'd get the x by itself by subtracting 4 from both sides, and that would turn that plus 4 into a 0, right? So here we don't want to make it a 0, though. It says x squared minus 4. So how can we turn that plus 4 into a minus 4? How about if we minus 8? So plus 4 minus 8 makes minus 4. Now we have that x squared minus 4 that we are trying to get. And 29 minus 8 is 21. So x squared minus 4 equals 21. Choice C. Next problem, and here's one to try on your own. Which of the following is a solution to the equation x squared minus 36x equals 0? You have 1 minute to try this problem. Go ahead. Your 1 minute is up. I hope that you were able to find the answer, and that is B, 36. Well, let's show you how this is done. So when I see an equation like x squared minus 36x, the first thing I notice is that x squared. That tells me that this is a quadratic equation, right? And quadratic equations, we can solve them by factoring or by using the quadratic formula. This problem is actually really easy to factor, and the reason why is because it doesn't have a third term. It has x squared minus 36x, and then no third term equals 0. That means that both of these terms have an x in them, so it's very easy to factor out one single x from both terms, and now our equation is factored. So we know that x times x minus 36 equals 0. That means that either x equals 0, the first term, or the second term, x minus 36 equals 0. And we can solve the second one and get x equals 36. So we have two solutions. Quadratic equations always have two solutions. Our two solutions are x equals 0 and x equals 36. So choice B, that has the 36, is our answer. Next one, now we have a system of equations. That's when you have two equations and two unknowns. We have an x and a y, two unknown quantities, right? So when you solve this, you get pairs. Notice that all your answer choices there are x, y coordinate pairs, and that's because you have to have an x value and a y value. So this is one of those times when it's helpful to write what you're trying to solve for up at the top, that you need both x and y, right? So this one, these are linear equations because they have a plane x and a plane y, and they're written in standard form. That's a number times x plus a number times y equals another number. When you have two equations in standard form, a really good method for solving them is to do a multiple of one equation and then add the equations together, and you do that so that you eliminate one of the equations. Okay, so when I'm looking at these equations, I notice that this top equation has just a plain x and the bottom one has a negative 2x. So if I multiply that top equation by 2, 2x plus 2 times 2y plus 4 times 2, right? Now I have a 2x. And the second equation, if I write it underneath, it has a minus 2x. So now if we added these two equations together, that 2x and the minus 2x would cancel each other out. Add the y's together and add those. And now we get our value for y. Y equals 3. So now is a good time to check. Of course, you want to go quickly on the ACT test. You have 60 questions and only 60 minutes in which to solve them on the ACT test. You don't want to waste any time that you don't have to. So I just got that my y value is 3. The first thing I'm going to do is look over at my answer choices and see if that allows me to eliminate any of the choices, and in this case it does. The only answer choice with a y coordinate of 3 is A, so I can stop. I don't even have to spend time solving for x because of the multiple choice format. All right, it's a really good idea to always look at your answers as you're working and see if you can eliminate answers as you go. Save yourself some time. So now let's pretend that there was another y equals 3 in the answer choices, and so we did have to solve for x, just so that you can know how to do it. All right, so what I'm going to do, we know our y value. Now you can pick either one of the two original equations and put that y value in to be able to solve for x. So let's pick the first equation here. X plus 2 times y, but now we know that y is 3, equals 4. So x plus 6 equals 4. And if we subtract the 6 from both sides to get the x by itself, we find that x equals negative 2, which is the x coordinate given in choice A. All right, but we didn't need to do that. But in case you do, now you know how. All right, next problem. Which of the following inequalities is equivalent to negative 2x minus 6y is greater than 2y minus 4? This is another one for you to try first on your own. You have 1 minute. Begin now. And that is 1 minute. And hopefully you were able to find that the answer was A. So let's go through this one. Inequalities can be tricky, especially when you're working with negative numbers. I'm going to show you why. Okay. So of course when we're looking at our answer choices, we see that the answer choices are all solved for x. So that means we need to try to solve what we've got here for x. So we need x on the one side of the equation and everything else on the other side. So I see this negative 2x term and it's got a negative 6y term with it. So let's move that, add it over to the other side. Okay. And now it's negative 2 times x, so we're going to divide by that negative 2. And make sure you have to divide everything by negative 2. You have a binomial on that other side, and both terms need to be divided by that negative 2. Now here's the trick. When you divide by a negative, it actually switches the direction of the sign. And then 8 divided by negative 2 is negative 4. Negative 4 divided by negative 2 is positive 2. Right, and that's choice A. So let's look for a minute. Why does it change the direction of the sign when you divide by a negative? Okay, so let's say that you ended up with something like this. Negative x is greater than 3. So to solve this, you could divide by the negative 1 in front of the x, right? And then why do we need to switch the inequality? Well, let's say instead of dividing, what if we added that x over to the other side? And then what if we subtract the 3 over to the other side? So now look at what has happened, okay? So up here, the x was on the greater than side of the inequality, right? Remember, inequalities are like the little mouth and they eat the thing that's bigger, right? This is eating the x. It's on the greater than side of the inequality. But down here, it is now on the less than side of the inequality. It switched sides. The inequality switched directions. Okay, and that is why when you divide by a negative, you have to switch the direction on the inequality. All right, number 6. During a snowstorm, the relationship between the depth of accumulated snow, y inches, and the elapsed time, x hours, was modeled by the equation 2x minus 5y equals negative 5. One of the following graphs in the standard xy coordinate plane models the equation for positive values of x and y. Which one? Okay. Well, what I see is I've been given a linear equation and it is in standard form, right? Linear equations have a couple different forms. If you have a number times x plus a number times y equals a number, that's like what we have. That's standard form. You could also have it in y equals mx plus b form, that's slope-intercept form, because m tells you the slope and b tells you the intercept. And there are different methods for graphing depending on which kind you have. Obviously, if you have the slope-intercept kind, you graph the intercept and then count by the slope to find the next point and connect them. But in this case, we have standard form. So what we can do with standard form is it's easy to find the x and y intercepts in standard form, okay? So the x-intercept is where it hits the x-axis. It intercepts the x-axis of the x-intercept. On the x-intercept, the y value is 0. So in order to find the x-intercept, you put a 0 in for y and then solve for x. The nice thing about that is when you put a 0 in for y, it makes the entire y term go away. Because anything times 0 is 0, right? So this all turns into one big 0. It goes away, and you're left with that 2x equal to negative 5, which is really easy to solve by dividing by the 2, and we find that the x-intercept is negative 5 halves, okay? So if you did a little sketch on your own, negative 5 halves is slightly bigger than negative 2, right there. All right, so what about the y-intercept now? So if we plugged in a 0 for the x, all this here turns into 0, and we're left with negative 5y equals negative 5. Divide, and negative 5 divided by a negative 5 is positive 1. So our y-intercept is positive 1. And now we can make our line here. So what we've been given is only this little section of the graph. But which picture matches the one that we've drawn? So it has a y-intercept of 1. None of these three have a y-intercept of 1. And then how is that line, what's the slope of the line like? Is it more shallow like A or more steep like B? It's like A. Okay. Next one. For all non-zero values of x, 12x to the 6th minus 9x squared all divided by 3x squared equals what? So basically we're simplifying here. We're simplifying a fraction. So a good strategy for stuff like this is you think of a number example. All you're doing is simplifying a fraction, right? If you were simplifying a number fraction, how would you do that, right? Like let's say you were going to simplify 12 out of 15, okay? How do you simplify fractions? You find something that both the top and the bottom are divisible by, right? So like, look at 12 and 15, well, those are both divisible by 3. And if I do that, I have now reduced the fraction to 4/5. So exact same thing. We're going to do the same thing, okay? So we have 12x to the 6 minus 9x to the 12 over 3x squared. You want to look at all three of those terms and say, what can I divide out of all three of them? Oh, my 1 didn't write in 12. There we go. So 12, 9, 3. Those are all divisible by 3, right? Okay. And then what about the x's? We've got an x to the 6th, an x squared, and an x to the squared. They all have at least 2 x's in them. So we can divide every term on the top and bottom by 3x squared. Okay, so 12 divided by 3 is 4. If we take away x squared, we're left with 4 x's. 9 divided by 3 is 3, and we took away all the x squareds. And on the bottom, 3x squared divided by 3x squared, anything divided by itself is 1. So that bottom is totally gone. And 4x to the 4th minus 3, choice E, is our answer. All right, here's another one for you to try. This problem asks, the three parabolas graphed in the standard xy coordinate plane below are from a family of parabolas. A general equation that defines this family of parabolas contains the variable n in addition to x and y. For one of the parabolas shown, n equals 1. For another, n equals 2. And for the third, n equals 3. Which of the following could be a general equation that defines this family of parabolas for all n greater than or equal to 1? 1 minute, go now. That's 1 minute, and I hope that you were able to find that the answer is A. So let's talk about this. This is one of the things that you need to know. It's like shifts and mother functions is what we kind of call these, the graphs of the mother functions. Those are lines, parabolas, cubic equations, x to the 4th, right? And you really should know the general shapes of the mother functions and how the numbers that make them up work. So what I see here is that the n equals 1 parabola is the widest, and then n equals 2 is next, and n equals 3 is the skinniest. So as n is getting bigger, the parabola is getting skinnier, okay? So how wide or skinny the parabola is determined by the number in front of the x squared, all right? And it's true that a bigger number makes a skinnier parabola. It's almost like slope. Think of the slope of the line. A bigger slope makes a steeper line. A bigger number also makes a steeper side on the parabola. Same thing, okay? So it's nx squared plus 1 because it's getting steeper and steeper. Choice B would make the parabola wider and wider because the n is in the bottom. And 1 over 1, 1/2, 1/3, those numbers are getting smaller, not bigger, so it would make the parabola wider. Right? X squared plus n, the n on the end of the x squared, the number after the x squared, that tells you where the vertex of the parabola is hitting the x-axis, which is at 1. That's why it's 1 here. If you look at choice D, a negative n, that would make the parabola upside down. Right? Positive gives you a smiley face, negative gives you a frowny face, right? They're negative. That's an easy way to remember it. But these parabolas are not upside down, so we know it's not choice D or E where our number in front of the x squared is negative. All right, next problem. Given 10 to the power of 2x minus 1 over x equals 1, x equals what? Okay, so this is an exponential problem, right? Because we have an x in the exponent. And remember from our last session that we had that formula where you could change exponent functions to log functions and back. We're going to use that right now. Remember, we'll write it backwards this time. Okay, if you have a number a to the power of b equals c, you can switch this into logarithm form. Okay, the base stays the base, and then the other two numbers switch positions. Okay, so that's what we're going to do here. We have 10 to the 2x minus 1 over x equals 1. So we're going to write a log, keep the base as the base, and then switch positions. So log base 10 of 1, that's just a number. All right, if you look on your calculator, you should have a button that says log. Okay, the log button, that is a log base 10 button, okay? In mathematics, we'll often write a log base 10 without the base. If you just see a plain log, that is log base 10. So in your calculator, you can type log 1, and that is log base 10, right? And if you type that in, you will get 0. That's equal to 0. Okay, and so 0 equals 2x minus 1 over x. Okay, so now I have an x and a denominator of fractions, so to get that out of there, we can multiply both sides by x. Let me just erase this stuff down here. So we have more room. Okay, x times 0 is still 0. And then the x in the bottom and the x have canceled out. Anything divided by itself is 1, so it is gone now. And now solve for this x. Add the 1 to both sides and divide by 2. And we get that x is equal to 1/2. Choice C. Next problem. This one is also an exponential problem. Whenever j and k are positive integers such that the square root of 3 to the power of j equals 27 to the power of k, what is the value of j over k? This is also similar to our very first problem where we're not solving specifically for either j or k. We're actually doing a manipulation again. We want to know what j over k equals. Okay, so this one's a little tricky. So remember from our previous session that a square root can be rewritten as the number to a 1/2 power. Okay, so square root of 3 is the same as 3 to the 1/2 power, and it's also to the power of j, so this is 3 to the 1/2 j. All right, so if I want to be working with those j's and k's, I need to get the bases the same. I need to write that 27 as a base 3 if possible. And you can do it. 27 is 3 times 3 times 3, or 3 cubed. So 27k is 3 to the 3k. Okay, now because those bases are the same, if the bases are equal, that means that their exponents must be equal. So we can set our two exponents equal to each other now, right? And remember, what we're trying to get here is j over k. So I have the j on the left here. I'm going to divide by the k on the right. And now I have a 1/2 j over k equals 3. To get rid of this 1/2, we'll multiply by the inverse fraction. And now I see that j over k equals 3 times 2, which is 6, divided by 1. Okay. Next problem. What is the sum of 0.1x squared plus 3x plus 80 and 0.5x squared minus 2x plus 60? Here's another one to try on your own. And remember the trick of ask yourself, how would you do this if this was just numbers, right? If you had two long digit numbers, how would you add them? And do the same thing here. So 1 minute, start now. Okay, that's 1 minute. And I hope that you were able to add these together and get that the correct answer is B. So if you were to add together two long digit numbers, you'd write them on top of each other and then add each digit. So we're going to do the exact same thing. And just like you would line up the ones digit and the hundreds digits and the tens digits, you have to make sure that you line up the x squared terms, the x terms, and the 60, right? We add up along the terms. Okay, and now we can add. 0.1 x squared plus 0.5 x squared makes 0.6 x squared. Positive 3 plus a negative 2 leaves us with positive 1. And 80 plus 60 is 140, choice B. And here's another one for you to try on your own. Solving a proportion, what value of x makes the proportion below true? So 1 minute, go ahead. That is 1 minute, and hopefully you were able to get that the answer is A, 2. So let's solve this. Remember, to solve a proportion, you cross multiply, and we're going to have to be careful because the proportion on the left has a binomial, 10 plus x, in the bottom. And remember, when you're multiplying something by a binomial, that means you're going to have to use distributive property to multiply by both terms. Okay? Yeah, so we did that. Cross multiply to solve. And we need to distribute this 35. Okay? So 35 times 10 plus 35 times x. And then 10 times 42. Now we need to get that x by itself. So let's subtract 350 from both sides and get it off of that left side. 420 minus 350 leaves 70. Divide the 35 off both sides to get the x by itself, and we get x equals 2. Next problem, which of the following ordered pairs in the standard xy coordinate plane satisfies the system of inequalities below? So now we have a system, but it's not equations, they're inequalities, okay? So there are two ways that you could go about this, okay? The first way is that you could take the choices that you've been given, A, B, C, D, E, and you can plug their x and y values into the three inequalities and see if it's true. We're looking for which satisfies the system of inequalities. That means that if you plug the point in, all three of those inequalities have to end up true. So for example, if we choose point A, 1, 3, x is 1, y is 3, and so we put 1 in for all the x's and 3 in for all the y's, are all three of those statements true? No. 1 is not greater than 2. So it's not A, right? And you can go through and continue to do that with all of the points, right? Plug in 2, 2 and see if that one's true. Plug in 3, 1 and see if that one's true. So that's the first way to solve it. The second way to solve it is to make a graph. Okay? So we sketch a little graph here. The graph of x is greater than 2. So we go on the x-axis to 2. X equals 2 would be the straight up and down line like this at 2. And we want x is greater than 2. So that's all this to the right of that line. Greater than does not include the line, okay? The line is not part of the solution. Remember what we talked about before. Greater than and less than are not included, but at least and at most are included. So these are not included. That's why we use a dotted line. Next we have y is greater than 0. So where y is 0, that's right along the x-axis here. And then we have greater than, so let's change colors here. So greater than 0, that's going to be up above that line. Okay. And where our inequalities overlap, that is where our solution is to the whole system. It's the overlapping area. Okay? So now we have one more left to go. And you can see that it is in standard form. X plus y is less than 5. So remember, standard form, the easiest way to graph is to find the x and y intercepts. If you put a 0 in for y, then you'd have x is less than 5. So our x-intercept is 5. Right there. And if you put a 0 in for y, for x, we have y is less than 5. Okay, so our y-intercept is also 5. There it is. And now we can connect these two lines, dots, with a dotted line because it's not included. The line is not included in the solution. And then we need to figure out where to shade. So it says x plus y is less than 5. And neither x or y are negative there. They're positive, positive x, positive y, less than 5. So we don't have to switch the sign of the inequality. So it's just a less than inequality there. So let's get a new color here. Okay, and we shade less than underneath the line. Okay, and so now we have a little solution area in here. This little triangle right here is our solution area where all three overlap. So any point that is a solution has to fall inside that triangle. So let's test our points. So the first point we have is 1, 3. That's not in the solution area. The next point we have is 2, 2. That is right on the line. And remember, the dotted line is not part of the solution, so that is not a solution. Next we have 3, 1. And look, that is right in the solution area, so the answer is C. Next problem. For all a greater than 0, which of the following expressions is equal to a to the power of -2? Okay, so this is just one of the things you need to know, sort of like how the square root of a number can be rewritten as the number to the 1/2 power. This is another exponent rule, okay? If you have a number to a negative power, you can rewrite that as 1 over the number to the positive power. Okay, so you have two important little laws of exponents that you need to know. All right, so in this case, we have a to a negative power. That means we can rewrite it as 1 over a to the positive power, and that is choice E. Next problem, for all real numbers x, such that x is not equal to 0, 4/5 plus 7 over x equals what? Here's one to try on your own, and remember, all you're doing here is adding fractions, right? What would you do if that x was actually a number? How would you add fractions? Okay, so you try it. 1 minute, go ahead. And that's 1 minute. And I hope that you were able to figure out that the answer is E. Well, let's take a look at this one. So remember, I said before, if you can't decide what to do, imagine that you had a number there instead of x. How would you add these fractions? Hopefully you remember that to add fractions, you have to have a common denominator, right? So 3 and 5, we can use 15 as a common denominator. And that means you'd have to multiply the top and bottom of this fraction by 5 and multiply the top and bottom of the other one by 3, right? And then that would give you a common denominator of 15. And then what you would do is add the tops together all over that common bottom. Okay, so now we're going to do the exact same thing, except we're going to have an x down there instead of the 3. So instead of a 3, we have an x, right? And so then our common denominator is going to be, oh, let's erase this one too. Our common denominator is going to be 5x, right? Whoopee. Okay. All right, so exact same thing. And now our common denominator is 5x. All right. So our top there is going to be x times 4. And our top on the other top side is going to be 7 times 5, or 35. And then remember, the last step is to add the two things on the top. They can't go together because they're not like terms, so we just leave them all over, whoops, sorry, all over the common denominator. The answer is E. All right, next problem. Which of the following values is the x-coordinate of the point in the standard xy coordinate plane where the graph of the line y equals 7 intersects the graph of the function y equals natural log x minus 2 plus 3? Okay, there's a couple ways to solve this. You could put it in your graphing calculator. put these two equations into the y equals, let's switch that back. So you can put this in y1 and this in y2 in your graphing calculator, and then you'll have to like zoom out until you find the intersection point, right? But of course the intersection point that the calculator gives you is going to be in the form of a decimal, and look at our answer choices that we have here. Those are not decimals, but what you could do is type each of these answer choices one at a time into your calculator to see which one is the same decimal that you got from the graph. So that's option 1. Okay. Option 2 is to realize that two different graphs will intersect at the point where they are equal. So in other words, where 7 equals the natural log x minus 2 plus 3. Okay, so my x is here stuck inside that natural log, so let's first isolate the natural log part. Okay, so 7 minus 3 is 4. So natural log is another one of those things, you'll have a button for it on your calculator. So we said before that the button of plain log, that is the same thing as log base 10. Your natural log is actually the same thing as a log base e, okay? So we can use our little change of base formula now, knowing that that's a base of e, okay? So keep the base the same, and then switch the other two parts, right? So now e to the fourth, that's something that we see in our answers here. Answer B has an e to the fourth, and you can see that if we keep going and add that too, we do get the e to the fourth plus 2, right? Always make sure that you have looked at your answers so that you can save time whenever possible, right? Eliminate answers, try to save yourself some time as you're working. Number 17, each of the following graphs in the standard xy coordinate plane has the same scale on both axes. One graph is the graph of ax plus by is less than or equal to c, where 0 is less than a, is less than b, is less than c. Which one is it? So here's another one to try on your own. You have 1 minute, go. And that's 1 minute. All right, the correct answer here is K. So let's go over how to do this one, okay? So again, anytime I see something like ax plus by less than or equal to c, that kind of stuff, it doesn't have any actual numbers in it, I always think, what if I did put numbers in and then see what it was like, right? Pick some numbers. So they tell us 0 is less than a, is less than b, is less than c. So let's pick some numbers that meet that, right? So in other words, c is the biggest, a is the smallest, and they're all bigger than 0. They're all positive. So what about like 2, 3, 4, right? And then just put those in. So if it was 2x plus 3y less than or equal to 4, okay? So remember, it's in standard form, which means find the y-intercepts, right? The x and y-intercepts. So if we plug in a 0 there for x, then the 2x turns into a 0, and we can solve, and we get y is 4/3. So y is a positive number, okay? So it's like up here, okay? And then if we put a 0 in for the y instead, and divided by the 2. So we get x is less than or equal to 4 divided by 2, or 2. So there's our x value right here, right? And it's a less than, oh, it's a solid line because it's a less than or equal to. Watch out for that. The less than or equal to means the line is part of the solution, so when we make it a solid line. And then it says it's a less than. It's a less than or equal to, so it's shaded below. Okay, so which one of our pictures matches what we've drawn? It's K. Number 18, for all real numbers x and the imaginary number I, which of the following expressions is equivalent to x minus 3i cubed? So if you remember last time we had one problem that was extremely time consuming, and this is another one of those problems. Okay, there's two ways to do this. One way is using a formula that you probably don't have memorized because it's one of the more obscure formulas. So the formula tells us that if you have a binomial, that's a difference of binomial cubed, when it's multiplied out, it's going to be the first term cubed minus 3 first term squared times second term plus 3 first term times second term squared minus the second term cubed. Okay? So if we want to do it this way, our first term is x and our second term is 3i. Because it's actually not a negative 3i in this case because it's not a negative 3i in this case, even though that negative is there because the negative is included in our formula. Okay? So be really careful with that. Okay? So if we're going to do this, all we need to do is plug in the x and the 3i for our a's and b's in our formula. So let's put x in for our a's. So instead of a cubed, it's an x cubed. 3x squared times b, which is 3i, plus 3a, which is x, times b squared, minus b cubed. Okay? Now let's simplify this down a little bit. Okay? Excuse me. So, x cubed. Next we have 3x squared times 3i. So 3 times 3 is 9, and then x squared and then I. All right, not too bad. All right. Okay, so next we're going to do the 3x times the 3i squared. Now, you have to be careful here. The entire 3i is being squared. Okay, so that's 3 squared and I squared. And same here, the entire 3i is being cubed. So that's 3 cubed and I cubed. That's a 27 there. And then right here we have 3 times 9 is 27i squared. Okay, so now we have all our terms, but there's one little trick, okay? The imaginary number I, it has a little definition that I squared is equal to -1. So if we see an I to a squared or a power greater than a square, then we need to evaluate that. All right, so we have our x cubed. This term here just has a plain I, but here we have 27i squared, positive. But I squared is -1. So that's really a 27 times a -1. That's a -27. Oh, and there was an x in there. We lost our x. Don't lose your x's. Okay, so now it's a -27x. All right, and then finally we have our -27i cubed. So an I cubed is like an I squared times another I, right? So in other words, this negative 27I cubed is the same thing as negative 27 times negative 1 times I. The negative times the negative is going to make it a positive 27, and then we have just the one plain I left over. So there is our answer, and we can see that it matches choice A. Okay? So if you didn't know this formula up here, what you would have to do is take your x minus 3i times x minus 3i times x minus 3i and multiply that whole thing out. So you'd have to FOIL the first two terms, first inside, outside, last, and then take your solution to that, which is going to have 3 terms, and multiply it by that next one. And this one you have to do what I call a super FOIL, where you times the x by each of the 3, and then you have to times the negative 3i by each of the 3, and then combine like terms. You'll end up with the same answer, but it takes a lot more time. Okay? Remember, if you're working and you get stuck on a problem and it is taking you a long time, just fold down the corner of your paper, put a circle around the problem in your booklet, and go on, okay? You want to do the faster problems, the ones that you can do. You want to get as many of those done as possible, right? If you end up running out of time because you spent a whole lot of time on just one problem and you miss, 5, 6 questions at the end, if you had skipped the one that you spent a long time of and been able to answer those 5 or 6 at the end, your score would be much higher, right? Instead of missing 6, you'd only miss 1. So make sure, if something's taking a long time, keep an eye on that clock and just skip it and move on. Come back to it later if you end up having time. If you totally run out of time and can't come back to it, it's fine. It's just one problem. You can quickly guess the answer, right? And you have a 1 in 5 chance of guessing it right. Whoops. All right, next one. So we have this Carrie's Chocolate Shop and Tamika's Treat Shop. This is the thing we looked at last time in the last session. And here we have another question using that same data, but this time it's an algebra question. It wants to know which of the following equations gives the relationship between the price in dollars C and the number of candies N in a box of candies at Carrie's Chocolate Shop. Okay? And if you look at these, you see the answer choices. Those are linear equations, right? And what do linear equations have? They have a slope and an intercept. So slopes are always measuring a change in something. They're measuring a relationship. We have the word relationship right here. So this is going to tell us our slope is the relationship between the price and the number of candies. Okay? It tells you what the slope is here. Now remember that slope is always a measure of change. It's how it is changing. All right, so when we look here at the chart, and you were using Carrie's Chocolate Shop, so we're going to look here at Carrie's prices. How are those prices changing, right? You have $1.50, $2.50, $3.50, $4.50, right? The price is changing by $1 every time. It's going up $1. How about number of candies per box? How is that changing? 5, 10, 15, 20, 25, 30. It's going up by 5. So our slope is 1/5. If you change that into a decimal, that's 0.2. And you can stop working and answer A, because of course you looked at the answer choices, right? Don't do extra work if you don't have to do it, right? That's very important. Time management is so key in these tests. All right, on to functions now. The function f is defined as f of x equals negative 4x cubed minus 4x squared. What is f of negative 4? So here's one for you to try. 1 minute, go ahead. Your 1 minute is up. I hope you were able to get choice D for your answer. So let's go over how you do this. So this is function notation here, and f of negative 4, that just means we plug negative 4 in for x in the function. So let's rewrite this function here. As negative 4 times negative 4 cubed minus 4 times negative 4 squared. There's a lot of negatives here. And if you messed up, it's probably because of the negatives, right? Okay, so 4 cubed, that's 4 times 4 times 4. You're going to have a negative 4 times a negative 4, which makes positive 16, times another negative 4, which changes it back to negative 64. And then negative 4 squared, negative 4 times negative 4 is a positive 16. Okay, so now we've got negative 4 times negative 64, which becomes positive 256. And negative 4 times positive 16 is negative 64. 256 minus 64 is 192. Okay, next one, temperatures measured in degrees Fahrenheit are related to temperatures measured in degrees Celsius by the formula F equals 9/5 C plus 32. There's one value of x for which x degrees Fahrenheit equals x degrees Celsius. What is that value? So we're going to do x degrees Fahrenheit, take our formula here. And we're going to switch it to make x degrees Fahrenheit and x degrees Celsius, right? And then we're going to find that value x. Okay, so let's get x. This one is 1x and that one's 9/5 x. So let's subtract 9/5 x from both sides. Okay. So this is tricky, and 9/5, you could change that to a decimal if you wanted to, right? Well, there's always a question, can I switch it to decimals or not? Can you put it in your calculator? And the way to tell is to look at your answer choices. If your answer choices have fractions in them, then you need to stay in fractions and work in fractions. If your answer choices don't have any fractions, then by all means you can switch to decimals. Okay, so if I type 9 divided by 5 in my calculator, then I get 1.8. So that's much easier to work with. It's 1.8. Okay, so 1 minus 1.8 is negative 0.8x equals 32. Okay, I can divide off this negative 0.8 from both sides. So 32 divided by negative 0.8, and I get negative 40, choice B. Okay? So you don't need to work in fractions if the answer choices don't have fractions, right? You can switch to decimals on your calculator. That's fine. Next one, students studying motion observed a cart rolling at a constant rate along a straight line. The table below gives the distance, d, feet, the cart was from a reference point at 1 second intervals from t equals 0 seconds to t equals 5 seconds. Which of the following equations represents this relationship between d and t? So if you look at your answer choices, you see again, we have linear equations here, and once again, they've used the word relationship, and that tells us what our slope is. Our slope is the relationship between d and t. And remember, slope is change. So we need to look at our little table of values here and see how our d and t are changing. So if I look at d, I've got 15, 18, 21, 24, 27, 30. It's going up by 3 every time. Meanwhile, our time, 0, 1, 2, 3, 4, 5, is going up by 1 every time. So 3 over 1 is 3. We have a slope of 3. So if you look at our equations, I can eliminate A, D, and E, because B and C are the only answers that have a slope of 3. So the last part of a linear equation is the y-intercept, right? A y-intercept is where it hits the y-axis, it's the zero value, it's like the start value. And we have a start value or a zero value right here in the table. It's 15. So our linear equation is going to be choice C. All right, next one. Given functions f of x equals 2x plus 1 and g of x equals x squared minus 4, what is the value of f of g of negative 3? This is what we call a composition of functions because you're going to combine or compose two functions together. The way that you do this is to work from the inside out, right? So we're going to work from the inside and do g of negative 3 first. And then once we have that value, we can plug that value into f. All right? So let's begin with g of negative 3. So we're going to take our g equation and plug in a negative 3 for the x. Okay? So negative 3 times negative 3 is going to be a positive 9. And 9 minus 4 is going to give me 5. Okay, now we're going to take this 5 and put it into f. We're going to find f of 5. Okay, so use your f equation and plug in 5 for the x. So we have 2 times 5, which is 10, plus 1. 10 plus 1 is 11. Okay, so composition of functions work from the inside out. Next one, the graph of f of x equals x minus 3 divided by x squared minus 2x minus 3 is shown below. What is the domain of f of x? This is one to try on your own. We'll see if you remember what a domain is and how you can tell what it is. Okay, so you have 1 minute. Begin now. And that's 1 minute. I hope you were able to figure out that the answer is D. So the domain of a function are all the x values for which a function is defined. Okay? So when we look at the graph, you're going to look along the x-axis and see if there are any places where the graph doesn't exist, right? And we've got 2 in this. This kind of graph right here is what we call a rational function, right? Rational ratio fraction. It looks like a fraction, okay? And their graph shape looks like what you see here. And we get something that's called an asymptote. It's an area where the graph is not defined. And that happens because fractions have something specific about them, right? 1 over x is the most basic rational function. That x is in the denominator, so it can't equal 0. You get an asymptote where x equals 0 because you can't divide by a 0. All right? So if you looked at the denominator of this fraction, x squared minus 2x minus 3, if you were to factor that, you'd get these factors x plus 1, x minus 3. Okay, and so if x equaled negative 1 here, you get a 0. If x equaled 3, you get a 0. And you can see there's also a little circle here on the graph, a hole at 3. And we have our asymptote at negative 1. So the graph is not defined at those 2 points. The domain is not defined there. So choice D is our answer. Okay, number 25. 3 copy machines A, B, and C copy at the same rate and will all be used to make copies of a report. At 8 a.m., all 3 machines begin copying. Machine A breaks down at 10 a.m. and is back in service at 1 p.m. Machine B breaks down at 12 p.m. and begins copying again at 3 p.m. All 3 machines finish copying at 5, when the copying of the report is complete. One of the following graphs shows n, the number of copies made, as a function of t, the time at any given point during the copying. Which graph is it? Okay, so this can help to make a chart of values so we know exactly what is happening, right? Okay, so we're going to have our time, right? And then we're going to have the number of machines copying. Okay? So it starts at 8 a.m. and it ends at 5. So we'll just sit here and go 8, 9, 10, 11, 12, 1, 2, 3, 4, and 5. Okay? So how many are copying? So at 8 a.m., all 3 machines are copying. Machine A breaks down at 10. So that means when we get here to 10, there's only 2 left copying. And it's not back in service until 1. But we see that machine B breaks down at 12 p.m. So at 12, we've only got 1 machine left. And then that first one is fixed at 1 o'clock. And then the second machine gets fixed at 3 o'clock. All right, so that's what we have. So obviously, the more machines that are copying, the faster the copying is going. A faster rate of copying means a steeper slope, right? So we should expect to have a really steep slope right at the beginning and right at the end. And then it gets less steep and even less steep. And then it's going to go back up a little bit, right? And then it's going to be most steep. Okay, so which graph shows us a picture of that? And the answer is F, right? F is most steep here at the beginning, and then it gets a little less and kind of levels out right there for the 1 hour where only 1 machine is copying. Goes back up a little bit and then all the way steep again. Okay, and you've made it to the final problem. The graph in the standard xy coordinate plane below is the graph of one of the following functions. Which one? Okay, so look carefully at that graph. You have 1 minute. Okay, begin now. And that is 1 minute. And hopefully you were able to figure out that the answer is D. Let's go over this one. This is a graph of a polynomial function. It's, again, one of the mother functions that you should know what the basic graphs look like. So polynomial functions are things like some number x to the 6th plus some number x to the 5th plus some number x to the 4th and so on like that. Okay? They could be it could start with x to any power, right? So that could have been an x to the 3rd and so on. Okay? The key is the highest power that tells you how many factors you have. So if you were to factor this, you'd have x minus some factor times x minus another one. You'd have 6 of those, okay? 6 factors. And those are the zeros of the graph. So we can tell what order of polynomial, right, by counting the direction changes on the graph. Okay, so here's how this works. The graph is going down, so there's 1, 2, 3, 4, and this is actually a little inversion here, 5, 6. This graph makes 6 direction changes. So like our example, we know that this started out as an x to the 6th polynomial, okay? So that means it has to have 6 factors. So if you look at our answer choices here, how many factors do these each have? So this one has 1, 2, 3. That one only has 3 factors, so it's not A. This one, the x squared, that counts as 2 factors because of the squared. So that's 2, 3, 4. Not B, right? Our next one here, this one has 2. That cubed means that that's 3 factors. And then this one, so 2 plus 3 plus 1, that does have 6. And so does choice D, 2 plus 3 plus 1. And so does choice E, 3 plus 2 plus 1. So it's either C, D, or E. Okay. So now how do we tell? Whoops. Okay. So what you want to do is look at the places now where it touches the x-axis. Sort of like you're zooming in on it. And what does it look like? If you zoomed on this first little section here, it's hitting at -4, okay? That means that the factor is going to be a +4 actually. And the reason why is if you solve this to be x equals, you'd have to subtract the 4. You'd get x equals a -4. So if you think backwards to make the factor, it's going to be an x + 4. And if you zoom in on that, that sort of looks like a linear equation, just a line. So this is just going to be a single x + 4, no exponent factor. Let's look at the next factor here, the next spot where it hits the x-axis. That hits right at 0, so that's going to be a plain x. And then what does it look like up close? It looks like a parabola, so that's an x squared. And then our final spot right here, that's hitting at +6, so our factor is going to be an x - 6, same reason. And the shape of that, like this, that's the shape of a cubic function. It's again one of the mother functions. You should know the shapes. An x squared, an x cubed, x to the 4th, right? And so on. X to the 5th, right? These are shapes of mother functions and you should know them, okay? So now we have our factorization and you can see that it matches choice D. Okay, and that is the end of our practice problems. So now that we've finished the problems, let's take a moment and reflect on our metacognitive strategies for this session. So first, assess. What strategies did you learn for solving algebra and function problems? And evaluate which problems were easy and which were hard. What were your strengths and your weaknesses? And finally, what will be your plan of attack for the algebra and function problems on the ACT test? We talked a lot about time management and being sure to look at your answer choices to see if you can eliminate answers and not have to work out the whole problem to save time, right? Things like that. What are you going to plan on doing? Thank you for taking this session, and make sure you do the next session, geometry and trigonometry.